Today we're going to solve exponential and log equations. Our objectives are to solve those equations, and our key question is, how can we make a log disappear? When we have an exponential equation, we have two options for solving these. These are the steps for the first option. First, we get the bases to be the same if possible. So you can see in the example here, I have two different bases, one that's 9 and one that's 27. So if we want to try to get those to be the same bases, what we do is we put a 3 as the base. Well, what does 9 equal? 9 is equal to 3 squared. So that would be 3 is my base. 3 squared was the original 9. And we still have 8 minus x in the exponent. Then the 27, well, 27 is equal to 3 cubed. So 27 is 3 cubed. And then we still have x minus 3. And our equal sign is still there. Next, if I have the 2 on the outside, I can distribute that through, and that's going to give me a 16 and a negative 2x, and this can give me a 3x and a negative 9, which now gives me 3 to the power of. So that was step 1. I changed both bases to the same number. Next, I'm going to raise a power to a power, which is multiplying the powers, which is what we did. I distributed the 2 through. Then I'm going to log both sides, because remember, if I log with a base that's the same as the base that's already there, they simply cancel out. For this one, I'm going to say log base 3 on both sides. Whatever I do to one side of the equation, I do to the other. What that does is it cancels out the bases, leaving only what was up top. And so that's going to simply give me 16 minus 2x is equal to 3x minus 9. At this point, we solve the equation like you would normally solve an algebra equation. And we're left with the answer x is equal to 5. For this problem, we're going to follow the same steps. We're going to try to get the same base. Well, here I have 1 over 64 and I have 2. For the 1 over 64, I want you to simply think of 2 to what power is equal to 64, and then we'll figure out the 1 over 64. Well, I know that 2 to the 6th power is equal to 64, but this is flipped upside down, so I put it 1 over, which means I'm flipping the 2 over, so it's a negative exponent. That's going to give me 2 to the power of x minus 1, that hasn't changed, is equal to 2 to the power of negative 6, and there was a 1 there already, so negative 6 times 1 is simply negative 6. Now I log both sides, and because I have log base 2 of 2, they simply cancel out, and I'm left with whatever is on top. Now I can solve the equation like a regular math equation, and I get the answer x is equal to negative 5. Here's another one similar to the last. What would my common base be? Here, my common base was going to be 5. So if I'm at 5, how do I get it to equal 1/5? Well, notice the 5 didn't change, but it flipped upside down. So that's going to be an exponent of negative 1. 5 to the power of negative 1, and the x minus 2 is still there. Then 5 to what power is equal to 125? Well, 5 cubed is 125, so that gives me 5 cubed, and there's already an x over 2 there. Now I multiply the negative 1 through, and I multiply the 3, which gives me 5 to the power of negative x plus 2 is equal to 5 to the power of 3x over 2. We log with the base of 5, which cancels out, leaving me with negative x plus 2 is equal to 3x over 2. At this point, you solve like you would a normal algebra equation. Give me a final answer of x is equal to 4/5. Now, unfortunately, we can't always cancel the logs out so easily. So if option 2 doesn't, or if option 1 does not work, then we go straight to step 3, and we simply log both sides of the equation. So for this one, I'm going to just simply push log, because there's no way I can get 4 and a 5 to be the same number. Now notice I didn't put a base to that log, which means it has the common log with a base of 10. The advantage of that is now I can use my calculators. Now if I'm going to solve this, remember whatever my exponent is goes into the front of the log right there. That means I'm going to have x minus 1 in parentheses times my log of 4, and that's going to equal log of 5. At this point, I solve the equation like I would normally solve an equation. I look at my x and say, what is happening to my x? Well, it's being subtracted by 1, but bigger than that is being multiplied by the log of 4. So I need to get rid of my parentheses. What's happening is being multiplied by log. The opposite of multiplying is to divide. So I divide by log 4. Whatever I do to one side, I do to the other. That cancels out, leaving me with, now what's happening to my x, it's being subtracted by 1. The opposite of subtracting 1 is to add 1 to both sides. At this point, you have two options. Some of your answers will ask for the exact value. This is an exact value, meaning it has not been rounded. However, some of them will ask for the approximate value. So we say x is approximately, and that's what a squiggly equal sign is, approximately. And I'm just going to round to the hundreds, 2.16. Now I do this by plugging in the calculator. Depending on your calculator, it can be easy or difficult. If you have one of the calculators where you can type things in, it's pretty easy. You just type it in exactly like that. If you don't have one of the fancier calculators, you're going to have to play around with it a little bit. Make sure that you are typing things in backwards, meaning you would say 5 log, then you push the divided by, and then you hit 4 log, hit equal, and then add 1 at the end. Alright, let's try another one. Here again, there's no way I could get a common base between the 3 and the 12.2. So what I'm going to do here is simply log both sides. Now notice I did not write a base, meaning our common base is 10, which means I can use a calculator. When I log something, I can bring that exponent down in front. Now the steps are going to be the same as the last problem. I suggest pausing, working it out on your own, seeing if you get it right. Now, here's a common mistake. When we're multiplying both sides by 2 to get rid of the fraction, remember, we're multiplying the entire other side, so that's going to use parentheses. Now, most books are okay with it right here. Occasionally, you'll need to distribute through so that you'd have a 2 in front of the log and then a minus 2 at the end. But because it will get complicated, most books are okay with it right here. And this would be your exact answer, and this would be what you plug into your calculator. Take care of the logs first, then subtract 1, and then multiply by 2, which is going to give you an answer of x is approximately 2.55. So that was solving exponential equations. Now, what if we're solving log equations? Here are the steps. First, put both sides of the equation to the base of the log. So we're trying to cancel out the log by creating a base. Whatever I do to one side, you also do to the other. Basically, whatever is currently there will be your new exponent, which is going to look something similar to this. If I have log base 6, that means I'm simply going to say 6 to the power of and 6 to the power of. That's all we have to do for step number 1. Now step number 2, because I have 6 to the power of log base 6, then the 6 and the log base 6 cancel out, leaving whatever was left in the log. So that's going to give me 2x minus 1 is equal to, and I have 6 to the power of negative 1. What is 6 to the power of negative 1? 6 to the power of negative 1 is simply 1 over 6. Remember, the negative exponent flips your number. Now, you'll simply solve the equation like you would solve a normal equation. I'm going to add 1 to both sides, and then we'll divide by 2. For those of you that don't remember how to add fractions, remember we're adding 1/6 plus 1. I need a common denominator, so my common denominator is 6. That gives me 1/6 plus 6 over 6, which is simply 7/6. And that gives me an answer of x is equal to 7 over 12. For those of you that don't remember how to divide a fraction by a fraction, we had 7 over 6 divided by 2. Remember, 2 is over an invisible 1, so that's a fraction divided by a fraction. When we divide fractions, we invert the denominator and multiply. So 7 over 6 times, and 2 over 1 flips upside down to 1/2. 7 times 1 is 7, 6 times 2 is 12. That's how we got to 7/12. So x is equal to 7 over 12. All we have to do is cancel out the logs by creating exponents. After that, it's basic algebra solving equations. Now for this one, we're combining some of the things that we saw before. Remember, if there's a subtraction sign, that means that we divide the insides here. That's going to give us a new log base 4 of 100 divided by x plus 1. Now we follow the same steps. We say 4 to the power of log base 4, which cancels out, and then 4 to the power of 1. That's going to give us a new equation of 100 over x plus 1 is equal to 4 to the power of 1 is simply 4. Now, to me, the easiest way of solving this is to cross multiply. And you're going to say, I can't cross multiply, I only have one fraction. Well, remember, we have two fractions, so we can easily cross multiply. When we cross multiply, the x plus 1 comes up and multiplies times the 4, and the 1 comes up and multiplies times the 100, which is going to look something like this. And we're left with an answer of x is equal to 24. Now again, from the last section, that's where we learned that when you subtract logs, you're dividing them. And we learned that 4 to the power of log base 4 cancels out. So those are all learned in the last section. Literally, this section, we just threw an equal sign in there and I haven't done anything new. Make sure you review 7-3 and 7-4. Here's another interesting one. More than one way of solving it, like most of these. Here's what I think is the fastest, easiest. We talked before about that exponent. The exponent comes down and sits in front, and put a 4 there. So I got rid of the 4 as an exponent. I put it in front. Now, if you notice from the left and the right, the 4 and 8 are divisible. So why don't we get rid of that 4 to begin with? I'm going to divide both sides by 4. And now I have log base 5 of x is equal to 2. So what it did is it made an 8 turn into a 2, my life a lot easier. I also got rid of some exponents. So now I can follow the same steps. So by using the rules that we learned before, you're going to make your life a lot easier. Could you have solved this without bringing the 4 down? Yes, definitely, but you would have had much bigger numbers. You would have literally had 5 to the power of 8 is equal to x to the power of 4. It would have been a little more difficult, but still doable. This is a much easier way of doing it. Now, we've already covered an exponent. We've already covered subtraction, which is division, and now we have addition, which is multiplication. So remember, I have log of the same base that's being added, which means I'm going to multiply the insides. X times x plus 1. That gives me log base 12 of x squared plus x is equal to 1. Well, I have 12 as my base, so I'm going to raise both sides to 12. And 12 to the power of 1 is 1. My logs canceled out. Now, I subtract the 12 over because I have a quadratic. So whenever we solve quadratics, we set it equal to 0. I can solve this by factoring, and that would give me x plus 4, x minus 3 is equal to 0. And then I'm left with x plus 4 equals 0, which means x is going to equal a negative 4, and x minus 3 equals 0, which gives me x is equal to a positive 3. Now here I have two possible answers. I need to plug it back in to find excluded values. And here's the really simple answer. You can never have a negative inside your log, which means x minus 4 is an excluded value and x equals 3 is your answer. If you try doing this, try taking the negative 4, it doesn't matter that the base is 12, simply put the negative 4, take the log of that, and put it in your calculator. It's going to tell you invalid input, or it's going to tell you error, something along those lines. You can't have a log with the negative 4 there, thus my only real answer is x equals 3. Now, like most of our log problems, we have a word problem. They're nice here, they give you which formula to use, and it says solve the compound interest problem. It says find how long it takes for $1,700. Notice $1,700 is going to be my initial amount, or my principal, to double. That's going to be our final amount. Well, what is 1,700 doubled? 1,700 times 2 is equal to 3,400. So that means my final amount is going to be 3,400. They've already given me 2 of my variables. If it is invested at 5%, again, we can't use the 5% as is. You have to move the decimal twice. That becomes 0.05. So my rate here is 0.05. Compounded monthly. Well, how many months are in a year? There's 12 months in a year. So that means my n is 12. And we're going to have 12 two places, which means we need to figure out the time. I knew that was my question because it said, how long does it take? So my variable is going to be t for time. Now we set up the problem. And then start solving it. So the first thing I'm going to do is get rid of that 1,700 from my parentheses. The opposite of multiplying is dividing, so I'm going to divide both sides by 1,700. And that gives me 2 is equal to. Now at the same time, I'm going to leave this 1 plus the 0.05 divided by 12 because I'm going to be plugging it into a calculator and I don't want to round. So when I actually plug this into my calculator, I'm going to plug that whole thing in just like that. And it still raised to the power of 12t. Now I need to solve for the variable that is in the exponent, which means I need to bring it down somehow. In order to bring it down, I simply log both sides. Once there's a log there, I can take that exponent and move it to the front. Once it's moved to the front, I can solve for it. Well, how do I get the 12t by itself? I'm going to divide both sides by 12 and divide both sides by log. I'm going to do it one at a time. Now here's a trick. Instead of dividing by 12 to both sides, and the left-hand side is stacking up with a lot of numbers, what I'm actually going to do is the same thing as dividing. I'm going to multiply by the reciprocal, and this is what it looks like. I'm going to multiply by 1/12. That's still dividing by 12. My 12 still cancels out, but the reason why that's helpful is when I'm plugging it into the calculator, it looks a lot better. And so this is going to give me an answer of t is equal to, I'm going to have that 1/12 on the outside times log 2 over log 1 plus 0.05 over 12. And you can put parentheses there if you want. You don't have to. If you're plugging these into calculators, I would definitely put a set of parentheses on both of those. This would be an exact answer. But if I ask you how long is something going to take and you give me that as an answer, I'm going to roll my eyes and tell you stop being a smart aleck. So we need to plug that into a calculator and you come out with 13.9 years. So at 5% interest, compounded monthly, it's going to take your $1,700, 13.9 years, or almost 14 years, in order to double your money. Now, a lot of these are going to ask you, well, what's 13.9 in months? In order to figure that out, you simply say 0.9 times how many months are in a year? There's 12 months in a year. Well, 0.9 times 12 is 10.8 months. We're going to round that up to 11. So our time would be 13.9 years. But if they're asking for months, then you would say 13 years, 11 months, because they probably would want you to round up.